This entry is on scatter plots, and scatter plots is a way to show statistics on a graph. Okay, so we have some statistics here, which is in the table, but oftentimes it's easier to show someone the stats you've collected if you can show it in a graph, because it's easier to look at, it's easier to compare, rather than just having specific numbers or even just a list of numbers. And scatter plots are really kind of similar to dot plots. So a way to remember a scatter plot is that scatter plots have lots of dots. Okay. So we have this information here on the left. I'll kind of zoom in a little bit. We've got age in one column and tablespoons of sugar per cup. Actually, I think TSP, that's teaspoons of sugar per cup. And so someone obviously went and did a survey, found a 7-year-old who likes 1.2 teaspoons of sugar, 15-year-old 1 teaspoon, 35-year-old 0.3 teaspoons, right? And they collected this data. And now that they have the data, they want to put it into a graph. So the first step that we want to do is we want to figure out which numbers are going to go where. Now this doodle notes is kind of nice in that it already kind of gives you the numbers here. You notice we're going up by 1/10 or 0.1, and here we're going up by 5s. So this one down here, this is probably going to be age, and this one is probably going to be teaspoons of sugar. So you want to make sure that you label it that way. Okay, so teaspoons of sugar. And at the bottom you've got age. And now what we're going to do is we're going to roughly, plot these points. So a 7-year-old, 5, 6, 7, probably about there, likes 1.2 teaspoons of sugar. So all the way up to 1.2. Is it going to be about there? Right. 1.1, 1.2, that's 7. 15-year-old, 5, 10, 15, likes 1 teaspoon. So you see what I'm doing is I'm just plotting those points. So I'll let you pause the video and you can go ahead and plot all of those points as well. Once you have all those points plotted, you want to make sure that you didn't miss any. So count the amount of data you have in your table. You should have 9. It means you should have 9 points plotted, unless there were any repeats. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Mine looks about right. I don't think I missed or left out any points. The one thing we do need to do though is give a title to our graph. It looks like we've got some coffee cups here. We're talking about sugar, age, so maybe a title could be amount of sugar people put in their cups. So I would write that right up here. Amount of sugar people put in their cups. And the next thing we're going to talk about is correlation. Now correlation, and I'm going to have you use a different color for this one because it's a definition. Correlation is how things are related. So how are these things related? So just down here. So how it's related. if those points that you plotted, okay, go up and to the right, that's called a positive correlation. Okay. And that means that as the age goes on, if these points are going up and to the right, like the arrow, okay, as the age gets larger, the amount of sugar gets larger. That's called a positive because it's increasing. Okay. Now, if you have a bunch of dots that look like this, okay, they're kind of just clumped together, this means there's no correlation. Okay. No correlation at all. It's not positive, it's not negative. There's zero correlation. That means that if it were to be this example, if these dots were kind of just everywhere, that the age, okay, and the teaspoons of sugar are not related at all. There's no trend there. So, for example, the amount of age, the age you are doesn't affect the amount of sugar that you want in your cup. If the dots go down and to the right, okay, that's called a negative correlation. You can kind of think of Joe as he walks. Right? Joe goes up and to the right, it's a positive slope. Down and to the right, it's a negative slope. So a negative correlation is when that data that you've plotted starts to go down. And in our case, it certainly looks like we have a negative correlation. They're about close to each other, right? And as the age goes on, the amount of teaspoons people like decreases, right? This person who's 53 doesn't like any sugar. Okay? So that's how we talk about correlation. And there's actually a number for correlation, okay, that you'll get into in algebra. So you can see how strong a relationship that is, whether it's no relationship or whether it's a really strong relationship. So yes, we have our graph here, right? We have a table. So a graph looks better than a table because we can show the correlation, right? And what actually even looks better than a graph is when we combine it with something called a trend line. And it's also called the line of best fit. F-I-T. Okay, line of best fit. And how you make a line of best fit is you use a ruler. Let me zoom in on this one. Use a ruler to draw a trend line that overlays the graph. So we're going to be drawing a line over the top of the graph, okay? And we want the same number of points on each side of the line. And that's just a good kind of rule of thumb when you're making these trend lines. So if I were to make a trend line, I wouldn't want to do one up here because I have a bunch of points below and none above, right? I wouldn't want to do it down here for the opposite reason. So to ensure that I go through and get a good accurate representation, we're going to have the same amount of points above as we do below. Okay, so you're going to use your ruler and you're going to decide, right, how many you need above, how many you need below. So we have 9 sets of data. That means probably 4 above and 5 below, or maybe 1 on the line and 4 above and 4 below that one. So go ahead and pause the video and you can make your trend line and I'll make mine. So here's my trend line in blue. You can notice that I put it right on this point here and I've got 4 below and 4 above. So my line roughly goes through the middle of the data, which is a pretty good representation of the data points. And this is really nice because using your trend line, you can actually estimate someone that's 20 years old. How much sugar would they like? Someone that's 40, how much sugar would they like? Right? So a trend line is really good for letting you estimate for those points that you don't have data for, right? Specific data, but gives you a nice way to estimate. And we can even get even more accurate by writing an equation of this trend line. Now, if you made yours and yours is different than mine, that's okay. The nice thing about scatter plots and trend lines is there are multiple answers that can be correct, as long as you can justify, right? You can say why your line fits. So it might be hard to justify a line that's all the way up here. Okay? But if you can justify it, then you'd be correct. Okay? It might be hard to do one down here. But again, if you can justify it, you're correct. If your line kind of goes more like this, right? That still might be a good representation. So there are a lot of different correct answers. I just happen to make this one. Yours might be different. But the process of what we're going to do is going to be the same. Okay? We can make estimations based on this line. Okay? And we can also write an equation and make a more accurate estimation. And that's what we're going to do next. We've gone over all forms of equations of a line, right? There's slope-intercept form, point-slope form, standard form. But when we have a trend line, okay, we're going to go back to that skill, and we're going to create an equation of that line, right, based on the data that we're given. Here, I'm not given a slope, but I can certainly find one, just counting the rise and the run. And I do have roughly a y-intercept. Okay? So we're going to put numbers into these boxes, right, for the slope and for the y-intercept, and that'll give me an equation for my trend line, which I can then use to make some estimations. So let's go ahead and get started with that. So I'm going to find two grid marks on my line that I can count the rise and the run from. And I'm going to use this one here, which I made smudges with, and let's see, what's another good one? Looks like this one right here. It's okay that this point isn't one of the data points that I'm given. I'm just using it so I can find the slope of this line. So what is my rise and my run? So let's count the grid marks. 1 grid mark, 2 grid marks, 3 grid marks going down. But notice that each grid mark is only 0.1. So I'm not going down 3, I'm going down, 0.3. So going down 0.3. And what am I going over? 1 grid mark, 2 grid marks, 3, 4. And it's not 4, it's actually, since I went by 5s, it's actually 20 in a positive direction. So let me stop using gray. That's not a very good color to use. So my slope is rise over run. That's going to be 0.3. Let's do that right here. 0.3 over 20. Okay, so that's my slope. My y-intercept is going to be where it crosses the y-axis. And that's going to be about here. And you're going to have to estimate it. It's not quite 1.1. Looks to me like it might be 1.08 maybe. So the equation that I would use is y equals 0.3 over 20 x plus 1.08. That's the equation of my trend line. And normally we don't like to have decimals inside of fractions, so you can change this if you want. So it's just a fraction without a decimal. And if you were to do that, you would get y equals negative 0.015x plus 1.08. So that's the equation of our trend line. Right, so this should have been negative. Now as we go down, we're going to answer some questions based on our data. What type of correlation do you see in the graph above? Well, as we said in the beginning of the video, it's going down and to the right. So that is a negative correlation. Which would you most likely, or which would you expect to be most likely for a 38-year-old? 0.2 teaspoons, 0.5 teaspoons, or 1.1 teaspoons of sugar? So there are a couple different ways we can actually do this one. We can look at our line and find 38 years old. Which is about here. And what is that closest to? Is it close to 0.2, 0.5, or 1.1? Right, so the answer, according to doing it this way, would be 0.5. Okay, 0.5 teaspoons. But I also want to show you how you could get an accurate estimation for a 38-year-old using your equation. So, x is going to be the age, right? That's the x value if you look at your graph. X value is age. So we're going to, and just do it in the margin here, okay? Write your equation, y equals negative 0.015x plus 1.08, and we're going to use 38 as our x value. So that's negative 0.015 times 38 plus 1.08. And we use a calculator, and we'll see what we get for our accurate estimation. And as we use the calculator and we did this math out, you would get y equals 0.51. So 0.51 teaspoons of sugar. Okay. So you're going to be asked to do this both ways. One way, by just using your trend line and saying where it is, okay, for 38-year-olds, what would be an estimation using your trend line. And the other way is to use the equation of your trend line and do some math to get that actual number. Okay, so you'll be asked to do it both ways. The last question we're asked, question 3, what type of correlation would you expect between these two variables, and explain why? So we've got x as the number of minutes taken to deliver pizza, and y as the number of stars given for customer rating. So what could we expect the correlation to be? Is it going to be positive, negative, or zero correlation? Do you think that it doesn't make a difference? One way to think about this is to think of a graph in your head. Okay? And if you can't do it in your head, you can do it on paper. So if this is the number of minutes, and this is the stars, what happens as the number of minutes increase to the stars of like a Yelp review, right? Certainly if you were to order a pizza and it was here in 0 minutes, you're probably going to get 5 stars. I would rate them 5 stars. Okay. If it took them 20 minutes, or 20 minutes actually probably isn't that bad. So 20 minutes might be like 4 stars or 3 stars. But let's pretend it took 2 hours, right? If it took 2 hours, they're probably only going to get 1 star. Whereas here they'd get 5. So what correlation do you think that's going to be? Right? Down and to the right. So that's a negative correlation. And the explanation is, okay, as the time waiting for the pizza increases, the rating will go down. Or it will decrease. So now that you've finished your doodle notes for the scatter plots entry, you're going to cut out the margins, okay, and maybe shave a little bit off the top here, and glue or tape that onto the next entry page of your interactive notebook. Now, we are going to want to try and keep this, okay, and this, and I'll show you how we do that in a second. If you cut this out, but cut around those margins, what you can do is fold them up, fold them in, okay, and then glue that page in. I'll just have some markings on here, but glue that page in so that when you flip open to it, you can open this, you can open that, and you've got that extra information that we used without having to waste another piece of paper. And that's it for the entry on scatter plots.